Hello coders, welcome to my video. So in this video we'll see about the new IPC technique that is used in Linux is a message queue. In the earlier video we studied about the FIFO, that is just a file in the kernel space where the one reader will pick a message that is written by the writer. Okay. So the kernel can only see the stream of bytes. Okay. They won't save anything. Okay. They only stream the bytes from that file, and the readers can read and write one at a time. Okay. But in case of the message queue, there are few different advantages that we have in spite of using the FIFO technique. Okay. So there can be the mix of messages, okay, in the message queue where each message is designed for a particular process. They can take that message, but it's not the case with FIFO. There is no priority of message in FIFO, but there are priority of message in message queue. Also, there is no message type, no sender identity in case of FIFO. So there are message queue that give us the reliable communication between the two process, that is A and B. Okay. So let's start with the message queue. So what I will do, I'll have two processes here, for example process A and B, and we try to communicate between the two process, and we'll study about the APIs that have been used in this message queue. Okay, let's open process A, and this process A will make it like a sender. Okay, so first of all, let's include the header files for this IPC. So we have sys message.h. Okay, then we have IPC.h. Okay, we can take studio.h, and we have string.h. So we'll take these all files, and in the main we have, and what I will do here, I'll just return 0 from here. Okay, then so the first step here will take a structure that we are going to send from process A to B. So we have struct message buff, for example, and this structure we have a long message type. Okay, and I have some data, for example message text, and I'll take it 100 for now. Okay, so this is our structure that I need to send to process B. Okay, so now I have an API named MSG SND. This API will send a message from this process to the another process. Okay, so this API have four parameters. So the first one is a message ID through which this queue is identified. So what I will do here, to make that ID, I'll create a random ID. For example, I will use ftalk, and here I'll generate some ID from here, that is of type key underscore key and key. Okay, then what will I do? I will use a API message get, and here I'll include this key to get the message ID through which this queue can be identified. So I have a key now. I'll give it some permissions. I will create it if it is not there. So create, and it will give me the message ID. Okay. So what I did here was I just input the key, random key. Okay, and I get a message ID. This message ID is unique throughout this system. And whatever process want to access this queue, which I will be sending this message, that is identified from this message ID. Okay, so now the first parameter I got it, so it is message ID. Second is our message. So I need to create the message. So how I will create it? I'll take string copy, simple, and first I have to create the structure. So struct message perf, and I have message, and here what I will do, msg dot m text. Here I will copy hello from process A. So this I'll put here, and I will give the address of this message now, give the size of this message here, and the last parameter, we have two parameters. Okay, so first is 0 and second is the IPC no wait. If I need to wait after sending the message, then I'll put 0, so it will go into a blocking state after sending the message. So maybe any other message we can send from the same API. Okay, but what I will do, IPC no wait. So after sending the message, this API will quit. Okay, and after sending the message, what I will do here, I will do printf. Then I have message send. Okay, then we have message dot m text. Okay, so I'm printing the message what I am sending here. So till now everything is understood. First I created the message ID, then I populate this array with this message, and then I use a message send command to send this message to this queue, and this queue is identified by this message ID in the kernel space. Okay, so this one is done. Second thing is I need to create the process B that will be a receiver now. Okay, so let's compile it. I'll compile this process A from process A.c. Okay, let's compile it now. It's working. Okay, so what I will do, I will take process A and copy process B. So most of the things remains the same here. That's why I'm taking it like that. So in receiver section, I think this message, this buffer, this structure I need. Okay. So this I have. I need this ftalk. I need this message ID. So similar is there. We have to keep the same name here. 65 is there, and I think 65 is here only. And this I need. So till now everything is same. So I will remove this section because I need to receive the message. So I will delete this, and here I will put message receive. So what is the message I received in this buffer? Okay. So now the API to receive the message from process B, sorry, the process A is MSGRCV. So this is the name of the API in system V that we are using. So here what I will do, I'll have the message ID similar, and now I'll take the address of message where I'm saving the message that I received. Okay, then I have size of msg.mtext, comma, then the message type I have. So for now, I only have one message, right? So I'll put like this. And last one is 0. I will be waiting for the message to be sent. Okay. So these all parameters. So this have the message type. I will explain it later. And here we have to wait, or we just have to quit. Okay. So I think it's fine now. So and I will compile it process B with process B dot C, and similarly I'll do for A. Okay. So now we have a process A as sender and process B as the receiver. So what I will do here, I will launch process A now. Okay. So this message has been sent, and it's been sent to the kernel, and it's been stored in the kernel buffer now. So if I want to see what is there in the message queue, so I can use IPCS-Q, and we can see there is one message that is there in the queue ID 6 with some key and have some permissions and number of bytes that is being used to save that message. Okay. So now I need to receive this message. So once it is sent, it is been saved in the kernel buffer. And now we have a reliable communication. This message will be there till we receive this message at a particular time. Okay. So for example, now I need to receive this message. So I will do process P at this time, and now I'll get a hello from process A. Okay. So this way I'm receiving this message. If I check the message queue again, that message is gone, but this ID is still there as I have not deleted it. Okay. So if I try to run this process again, if you see again, you get a new message again, and again, if you to process B, you will get a message, and now there is no message. Okay, so now what I will do, I'll just take process B now, as there is no message in the queue, still to keep on monitoring the queue till the message is there. So in the second terminal, I will send this message to the same queue. When I enter this, the message is gone, and if you see in the receiver terminal, you get a message there. And but this message ID is still there as we have not deleted it. So in order to delete it, so what I will do in the process P where I am receiving this message, after receiving this message, what I will do, I'll just remove this message queue, and there is an API msg there I will give message ID same. So message ID is the key. Okay. And then we have a flag IPC RMID, and third is null. So by doing this IPC RMID, we are going to delete this queue mapped to this message ID. So what I will do now, I'll just save it. I will take it like this. Okay. So now if I see, I have this message queue ID, but if I run process A again, I get a message now, and from the other terminal, process B, I got this message. Okay, and now if I read this, there is no queue over to the kernel space. Okay, so this is helpful by communicating asynchronously to different processes. Okay, so it's just like a post box where I am sending the message. It is there in that post box until we go there and we take the message at a particular time. So maybe we'll go in the morning, maybe we go in the evening. So it doesn't matter. So the point is that message got stored in some location for infinite time until we have a receiver. So this message queue is being used in lot of real-time applications as well. See in the next video. If you have any comments, just post it there. Okay.